Welcome back to PrepForge. Today's topic is Heroku, one of the original and still one of the clearest examples of a platform as a service or PaaS. Here's the one-line pitch. With Heroku, you don't manage servers at all. You push your code and Heroku builds it, runs it, and scales it for you. No provisioning machines, no installing operating systems, no configuring load balancers. In this video, we'll cover Dynos deploying with a simple git push, Buildpacks and Slugs, the Procfile, config Vars, add-ons, scaling, and the one gotcha that trips everyone up, the ephemeral file system. By the end, you'll understand exactly what a platform as a service gives you and what it takes away. Let's get started. Let's start with the problem. To run an application the traditional way, you have to do a mountain of work that has nothing to do with your actual product. You provision servers, install and patch the operating system, configure networking and firewalls, set up a load balancer, wire in a database, build a deployment process, add monitoring. That's weeks of undifferentiated heavy lifting before your code ever serves a user. A platform as a service flips this. You bring your code and the platform manages everything underneath it. The servers, the operating system, the runtime, the scaling. Heroku was the service that made this idea famous. You focus on your app. Heroku handles the rest. Concept 1. What Heroku actually is. Heroku is a platform as a service, so it helps to place it on a spectrum. With infrastructure as a service, like a raw cloud virtual machine, you're handed a bare machine and you manage everything above it, the operating system, the runtime, your app. With software as a service, you don't bring any code, you just use a finished application. Heroku, as a platform as a service, sits in between. You manage only two things, your application code and its configuration. Heroku manages everything else, the operating system, the language runtime, the servers, the load balancing, and the scaling. The trade is simple. You give up fine-grained control, and in return you ship in minutes instead of weeks. Concept 2. Dynos. The unit of computing in Heroku is the dyno. A dyno is a lightweight, isolated container that runs a single command, your application. Your app runs inside one or more dynos. There are different types. Web dynos receive HTTP requests from the outside world. Worker dynos run background jobs, like sending emails or processing a queue, with no web traffic. To handle more load, you simply run more dynos of a given type. That's horizontal scaling. And here's a defining trait to remember. Dynos are ephemeral. They're spun up and torn down freely, and every dyno restarts at least once a day. That single fact shapes how you must design a Heroku app. Concept 3. Deploying. This is the feature that made Heroku legendary. To deploy, you run one command, git push Heroku main. You push your code, exactly like pushing to any git remote, and Heroku takes over. It detects your programming language, installs your dependencies, builds your application, creates a version release, and starts your dynos running the new version. Moments later, you have a live URL. You never touched a server, and because every deploy is a numbered release, rolling back to the previous version is a single command. That push to deploy simplicity is the whole reason developers fell in love with Heroku. Concept 4. Buildpacks and Slugs. So how does a git push turn into a running app? Through Buildpacks and Slugs. When you push, Heroku runs a build pack, a script that detects your language, Node, Python, Java, and knows how to build that kind of app. The build pack installs your dependencies and compiles anything that needs compiling. The output is called a slug, a compressed, pre-built, ready-to-run copy of your application. When a dyno starts, it simply downloads and unpacks that slug and runs your command. This is why boot up is fast. The heavy building already happened once, and the resulting slug is reused across every dyno. Heroku provides official build packs for all the major languages. Concept 5. The Procfile. How does Heroku know what to run? Through a small text file called the Procfile, which lives in your project's root. Each line declares a process type and the exact command that starts it. The most important is the web process, the command that starts your HTTP server, because only the web process type receives web traffic. You might also declare a worker process for background jobs. Once these are declared, you can scale each process type independently, say, 3 web dynos and 2 worker dynos. The Procfile is how you tell Heroku the shape of your application. Concept 6. Config Vars. You should never hard-code things like database URLs, API keys, or environment settings into your source code. Heroku handles this with config Vars, which are simply environment variables attached to your app. You set them once. For example, Heroku config set database URL, and Heroku injects them into every dyno at runtime. This means the exact same build slug can run in staging and in production, with only its config Vars different. That separation, code in the slug, configuration in the environment, is a core principle of what's called the 12-factor app, and Heroku enforces it beautifully. Concept 7. Add-ons. Your app usually needs a database, a cache, maybe a search index. Heroku provides these through add-ons, a marketplace of managed services you attach with a single command. Heroku Postgres, Redis, and many third-party services, logging, email, monitoring, are all one command away. And here's the elegant part. When you attach an add-on, Heroku automatically creates the right config var for it. For example, attaching Postgres sets your database URL. Your app reads that config var and just works. Add-ons are how you get a fully managed database without ever managing a database yourself. Concept 8. Scaling, and the gotcha that trips everyone up. Scaling on Heroku is easy. To scale horizontally, you run one command to set the number of dynos, say 5 web dynos, and Heroku load balances across them. To scale vertically, you switch to a larger dyno type with more memory and CPU. But here's the single biggest gotcha in Heroku and a favorite interview trap. Each dyno's file system is ephemeral. Anything your app writes to local disk is temporary, and it is wiped every time the dyno restarts, which happens at least daily, and on every deploy. So if a user uploads a file and you save it to the dyno's disk, it will simply disappear. The rule is absolute. Store uploaded files in a service like S3, and all your data in a database add-on. Never rely on the local file system for anything that must persist. Concept 9. When Heroku is the right tool. So when should you reach for Heroku? Use it when developer speed matters most, for startups, minimum viable products, prototypes, and small to medium applications. Heroku lets a tiny team ship and iterate incredibly fast, with almost no operations work. When should you reconsider? At large scale, a platform as a service can become expensive compared to running your own infrastructure on raw cloud. And if you need deep control over the operating system, networking, or special hardware, a platform as a service deliberately hides those from you. Said simply, Heroku trades control for productivity. You give up knobs and you gain speed. Explain the push-to-deploy flow and the ephemeral file system, and you've shown you truly understand what a platform as a service is. And that's Heroku, end-to-end. A platform as a service where you push code and it runs, your app living in ephemeral dynos, deployed with a simple git push, built by Buildpacks into a slug, its processes declared in a Procfile, configured with config Vars, backed by managed add-ons, scaled with a single command, and never, ever relying on the local disk. It's maximum developer productivity in exchange for less control. Explain push to deploy and the ephemeral file system, and any interviewer will see you get platform as a service. If this helped, subscribe for more. Thanks for watching, and good luck in your interview.